This is indefinite integral. Indefinite integral, we will be using this one as our symbol for integral sign, and then this one is our what we called as the integrand. Okay, so I will be writing here uh, an example of an integral. So to start with, we will have this basic. Okay, so the integral of dx, or let's say du. The integral of du, by the way, this is not an example, but we have to follow this format. In the integral of du, that is equivalent to u plus c. Okay, so integral of du. Integral is the antiderivative of your function. So if you have here your d as your dx, that is, d stands for the derivative. This is antiderivative, and then d is your derivative. So if we integrate this one, what remains here is your u. Okay, example of this one, let's say example 1. Example 1, I will write this one as example 1. Okay, let me check. Example. We will have here our example using this first formula for integral or indefinite integral. So we have here number 1, the integral of, let's say, dx is equivalent to x plus c. Take note, this stands for derivative, and then this symbol is the antiderivative. So all you have to do is to cancel this one. What remains here is x. So, and then this one is c. This is your constant. So c stands for your constant. If we say constant, that is any number. Another example, we have here the integral of, let's say, dy, that is equivalent to y plus c. And also, we have here, let's say, 3, the integral of dz, that is equivalent to c plus c. So these are just an example of our basic formula, that is the integral of du, which is equivalent to u plus c. If we apply a number, let's say number 4, for dx, then that is equivalent to, you write first this number 4, you have your 4 integral of dx, and so the integral of dx equals x times 4, that is 4x plus c. In indefinite integral, you always have this plus c, your constant. Another example, let's say the integral of 5 dx. So that is equivalent to 5 times the integral of dx, which is equivalent to the integral of dx equals x times 5, that is 5x plus c. Another one, let's say number 6, the integral of dx over 3. 3 is your numerator, so you can write directly your numerator, and then you have here 1 over 3, your number, integral of dx. So that is equivalent to 1/3 of x plus c. And if you have, let's say, 7, the integral of, let's say, 4 dy over 3, that is equivalent to, of course, 4 over 3. The integral of dy equals y plus c. So that is just an introduction of indefinite integral. We have here the basic formula, which is the integral of du equals u plus c, with, of course, a number here. And of course, we have here your x, uh, we call this one the integrand. Okay, now we will proceed with another example. Okay, So take note, if we have the integral of du equals u plus c. So I am rewriting again this formula, du equals u plus c. So what if we have, let's say, we will have another formula, okay, the integral of u to the n du. So actually this is a power formula. We have u to the n plus 1 over n plus 1 plus c. Take note, if this is our u, then the derivative of u equals du. So u to the n du, that is equivalent to u raised to n plus 1 over n plus 1. So this is another formula. So we have here formula 1, and then another formula, we have this one, u to the n du, which is equivalent to u n plus 1 over n plus 1. So another example for this new formula. So we have now two formulas. Number 1, example 1. This time we have the variable, let's say if this is u, then we have the variable u. This time we will be using x, so the integral of x dx. Okay, when we solve this one, our u here is x. When we use this formula, our u is x. Then the derivative of u equals dx. So let u equals x, so that the derivative of u, the derivative of this one equals du, which is also the derivative of x, that is dx. We have here dx, we have here your x as our u. So u, our n is 1 for this case, n is equal to 1. So I am rewriting here n. N is equal to 1 for this case, 1. So if we apply this formula, n is equal to 1 for this case, and then our u, we have here x. So u equals x, and then the derivative of this u equals derivative of x. So we will take the derivative to both sides. So dx, which is equivalent to this one. Therefore, it follows that this one is equivalent to un plus 1 over n plus 1. Our n is 1, so that becomes x raised to 1 plus 1 over 1 plus 1 equals c, which is then equivalent, oh no, it's not equals to c, but plus c. Okay. Which is equivalent to x squared over 2 plus c. Another example we have here, I will write a number. Let's say 2x to the 4th dx. Okay. Now, our u here is x. Of course, number 2, we write 2 integral of x to the 4th dx. So for this case, our u equals x. The derivative of x equals dx. So we have here u n plus 1. We will follow this formula. Therefore, that is equivalent to 2. Okay. 2x raised to 4 plus 1, that is equivalent to 5 over 5 plus c. So our final answer is equivalent to 2 over 5 x to the 5th plus c. That will be our final answer for this particular problem. Now, what if we have number 3, example number 3, what if we have this one? Let's say integral of 3 plus 4x squared dx. If we have this one, 3 plus 4x squared dx, then of course we just distribute this dx to 3. So integral of 3, okay, I will directly answer this one. I will write first here, 3, I will distribute dx first to 3, or you can directly answer that one. Dx plus 4 integral of x squared dx. In other words, I am distributing dx to each function. 3 dx, so we have here 3 dx, and then we have here 4x squared dx. 4x squared dx. Distribute integral sign to each function, so that this one, the integral of dx, integral and then d will be cancelled, so 3x for this particular function, so that this is equivalent to 3x. And then this one, this is 4 integral of x squared equals x cubed over 3 plus 4 x cubed over 3 plus c. So that will be our final answer for this number 3. Okay, and then what if we have here another problem? Let's say the integral of okay, uh, 5 plus 2x squared dx. So all you have to do for this one is you have two options. You can use substitution, which will be discussed later on, or you can expand this problem. I mean these functions. So when we expand this one, this is binomial. Squaring of a binomial, okay, that is equivalent to the integral of 5 times 5, that is 25, plus 2 times 5, 10 times 2, 20x. 20x plus 2x times 2x, that is 4x squared. Okay, dx. So we expand 5 plus 2x times 5 plus 2x. This is the result. So that when we integrate this one, that is equivalent to the integral of 25, that is 25x, plus the integral of 20x, that is 20x squared over 2. Your x here, the exponent is 1. So 1 plus 1 equals 2 over 2. You have here 2 over 2. And then for this one, plus 4x, 2 plus 1 equals 3. So you have here x cubed over 3 plus c. And then this one can be reduced to 20 divided by 2, that is 10. So that the final answer now is 25x plus 10x squared plus 4 over 3x cubed plus c. So that will be our final answer for this particular problem. Okay, now notice this one. If you have noticed, okay, try to look at number 1. In number 1, so I will change first the color of my pen. Okay, if you have noticed in number 1, okay, try to look at number 1. Our final answer is x squared over 2 plus c. If we take the derivative of this one, when we take the derivative with respect to x, because this is x, then it will equate to the derivative of x squared. This is 1/2. The derivative of x squared equals 2x times the derivative of x, or dx. Okay, 2x dx plus the derivative of any constant, that is 0. Okay, or I will erase this one. Okay, if I will apply d as a derivative of x squared over 2, so 1/2, I will separate 1/2, and then derivative of dx squared equals 2 dx, 2x dx. So we have this one, and then derivative of c, and then this 2 over 2 will be cancelled. So what remains here is x dx, which we go back to our problem in integral. So that is antiderivative, x dx. In other words, why I'm showing this one? If this is your answer, for example, this one, if we have here your answer, if we take the derivative of this one, so let's say derivative of this one, that is 2 over 5, derivative of x to the fifth equals 5x to the fourth dx. So that derivative of constant is 0, so cancel 5. So what remains here is 2x to the fourth, which is equivalent to this one. Of course, you have here your dx. Okay, so you will go back to your initial problem in antiderivative. Okay, so you can check your final answer by taking the derivative, and of course you will go back to the given problem in integral. So you can have you can check your final answer. Okay, so this is now the integral of u to the n du. Now what if we have an exponent, or it's a like for example this one. I have mentioned a while ago that you can solve this problem in two ways: by expanding this 5 plus 2x you have here. When we expand, the result is this one. Or another way of solving problem is by applying U-substitution. Okay, so in U-substitution, we will have this one as our U-substitution. So take note, we have here our formula. Okay, I will be using violet because I used it a while ago. Okay, the integral of u du equals, sorry for that. Okay, the integral of du equals u plus c. The other one we have here, the integral of u to the n du, that is equivalent to u n plus 1 over n plus 1 plus c. Now, we will now proceed to u substitution. U-substitution. Now, in U-substitution, we will still be using these formulas. Okay? We go directly to our example. Okay. Now, example number 1. Okay. We have here 5 plus 2x raised to, okay, a while ago we solved problem 5 plus 2x raised to 2 dx. 5 plus 2x raised to 2 dx. So using u substitution, we have to identify our u. So for this case, if we use this formula, our u can be identified as 5 plus 2x. And of course, our n, for this case, that is equivalent to 2. Okay, so I will erase that one. At least we identified our n as 2. So we go back to our u. We will focus our u because this is u substitution. And then when we take the derivative of our u, you have here our u du. Take the derivative of this one, which is equivalent to take the derivative of this one. The derivative of 5 is 0, and then the derivative of 2x equals 2 times the derivative of x. Okay, 2 times the derivative of x. Now, again, if we use this formula, if this is u, then this must be du. So for this case, if this is our u, then this must be our du. So if our u is 5 plus 2x, then our du is 2 dx for this one. Since this is dx, now I will rewrite this one as 5 plus 2x squared. Okay, this one. Since this is dx and then this one is 2dx, so I will write here, I will copy this one, dx, 2dx. Okay, I will erase 2. Okay, I will copy that one later on. Now, if I will copy here, if you have noticed, there is a change. If this is dx, then this one is 2dx since I copy this one. And because I am writing here 2, because I copied du as 2dx, then I will multiply 2 by its reciprocal. So the reciprocal of 2 is 1/2. Okay. Why do I need to write 1/2 here? The reciprocal of 2. Now, try to look at this one. If I am going to highlight this 2, 1/2, and then this 2, if you have noticed, the integral of 5 plus 2x raised to 2 dx, that is equivalent to this one. Right? But because our du is 2dx, then I need to write 2. And when I write 2, I have to write here its reciprocal, 1/2. So that when we multiply 1/2 by its reciprocal, that is equivalent to 1. In other words, this equation is equivalent to this equation. This one, I am just presenting this one in another way, which is also equivalent to this one. However, this what we call as another way of writing is based why it appears to have this 1/2 and 2. This is based on du. Now, why do I need to base our du as 2dx? It's because our formula is u to the n du. I must satisfy this formula. Okay? So that this one now is equivalent to, okay, this one is u to the n. This one. And then this one will be our du. So that the integral of du over u, take note, that is equivalent to u n plus 1 over n plus 1. Take note, integral of u to the n du equals un plus 1 over n plus 1. Therefore, to answer this problem, I will go back to violet. This is now equivalent to, of course, 1/2. And then the integral of u to the n du equals un plus 1. What is my u? My u is 5 plus 2x. And then n plus 1. My n equals 2 plus 1, that is 3 over 3. Plus c. I am now following this formula. 1/2. We have here 1/2. And then u to the n du, which is equivalent to u. This is u. N plus 1. That is u. 2 plus 1 equals 3 over 3. We have this one. Okay, so that we have our final answer, which is 1/6. 2 times 3, that is 6. And then 5 plus 2x raised to 3 plus c. If we look at our value here in our previous problem, we have this one. 25x plus 10x squared plus 4/3x cubed. If you have noticed, this is raised to x cubed. If we expand this one, this is, we will arrive to that equation as x cubed if we expand this one raised to 3. Okay? So, let us try to expand this one. Medyo mahaba, so hanggang dyan na lang muna. So, equal lang yan sila. They are equal. If we take the derivative of this one, it will go back to this value. It will go back to that value. Okay? So, they are equal with the previous example. Okay, another equation. We have, example using U-substitution. Okay. So, let's say the integral of 3 minus 4y raised to 5 all over 4 dy. If we apply this formula, we have to determine our u. But because we have here this is a fraction, I will write first 1 over 4. I will write it first as 1 over 4. The integral of 3 minus 4y raised to 5 dy. Okay? So, we have to identify what will be our u. Our u here equals 3 minus 4y. And then our derivative of u, the derivative of this one, that is negative 4 dy. So du equals negative 4 dy. If you have noticed this one, the difference here is this is negative 4 dy and then this one is dy. Okay? So their only difference is negative 4. If, take note of this one, if this is your du and then we have here your problem, if the only difference is in number only or sign, positive or negative sign, then that is acceptable or that can be applied or that can be solved using this particular formula if you want to use this one. In other words, if you have here a problem, you have to identify what particular formula are you going to use. So for this case, we want to use this formula. So if we want to use this formula, we have to check our u. Okay, this one. And then du we have here. Once the difference here is only a number or the sign, then we can use our suggested formula, which is u to the n du. There are a lot of formula in integral, but then you have to test your u before you can apply that formula. Okay, so going back to this one, the difference here is negative 4. So our solution now is 1/4. I will write it first. 1/4 the integral of 3 minus 4y raised to 5. Now instead of writing dy, I will write negative 4 dy. Negative 4 dy. Of course, I will write here open and close parenthesis because we have here a negative sign. And then the reciprocal of negative 4 is negative 1/4. Okay, we have this one. Okay, let me rewrite this value. I have a limited space, 1/4, and then negative 1/4. Okay, the reciprocal of negative 4 is negative 1/4. Take note of this one. Okay, so the original is 1/4. We have this one, and then integral of 3 minus 4y raised to 5, and then dy. Since we have in our du, we have negative 4, so I will write here negative 1/4. Therefore, this one is now is the integral of u to the n du. So that when we solve this one, 1/4 times negative 1/4, that is equivalent to negative 1/16. And then u to the n du, we have here 3 minus 4y, our u. 3 minus 4y, our n equals 6. 5 plus 1, that is 6 over 6 plus c. So that when you multiply this one, the final answer is negative 3 minus 4y raised to 6 all over 6 times 6, that is 36, carry 1, 6 times 1, 6 plus 1, 7. 6 times, 9, sorry for that, that is 9. Okay, so I will rewrite it. 6 times 6, 36. So 96. 6 times 6, 36, carry 3, 96 plus C. This will be our final answer. Example 2, using U-substitution. Okay, U-substitution. additional example for U-substitution. So take note again, the integral of du equals u plus c, and then the integral of u to the n du, which is equivalent to un plus 1 over n plus 1 plus c. Okay, so we have here we have two example. This time example number 3, this is just a continuation. Okay, what if we have another example? Let's say the integral of 3 of 4x plus 1 raised to 3 dx. So we will make use of U-substitution. So we will write first 3 integral of 4x plus 1 cube dx. So our u for this one equals 4x plus 1. If we make use of this formula, so the derivative of u, that is 4 dx. And then this one is dx. So again, we will write here 3. And then reciprocal of 4, I will write directly the reciprocal of 4, which is 1/4 integral of 4x plus 1 raised to 3. You have here 4 dx. This is 4 dx. This is supposed to be our du. So this is u to the n du, 4 dx. So that 3 over 4, that is 3 times 1 over 4. And then this one, you have here 4x plus 1 raised to 3 plus 1, that is 4 over 4 plus c. And then that is equivalent to 3 times 4 times 4, 16. So 3 over 16, 4x plus 1 raised to 4 plus c. That will be our final answer. Okay, example 3. Now, what if example 4, we have this example, the integral of x squared, 9x squared, plus 2, let's say x dx. Okay, and then we have here 4. For example, I will erase x first. I will rewrite this problem. Okay, 9x squared plus 2 raised to 4 dx. Remember our formula, we have this one. Okay, if we use u to the n for this part, the integral of u to the n du, because this is our initial formula, then we have to identify our u. Our u, for this case, u equals 9x squared plus 2. And then the derivative of our u, du, equals the derivative of 9x squared equals 2 times 9, that is 2 times 9, 18 x dx. Okay, 2 times 9, 18x dx. And then derivative of 2 is 0. So we have here 18x dx. However, this one, if you have noticed, this is dx. This one is dx. And then this one is x dx. Okay, I will write it here. This one is dx. And then this one is 18x dx. If you have noticed from our previous example, we apply this formula because we have only a number, that is the difference between du and then the given problem. If this is dx, then we have here 4 dx. Okay, I will write it here. If this is dx, our problem is dx, then our du is 4dx. So we allow this formula because the only difference is this one is x, this one is 4. I mean dx, and then this one is 4dx. The difference is the number only, or let's say sign, negative sign or positive sign. So for this case, number only. However, this one, if this is dx and then this one is 18x, so you have here the variable x. You have here a number and then you have here x. If this is the case, you are not allowed to use this formula. Okay? So, you are not allowed to use this formula because if you use this formula, your u is 9x squared and then du is 18x dx, which is different from this one. So you are not allowed to use that formula. Instead, you will be using another formula, or you can expand this one. Okay, so you can make use of other formula. Okay, so that can be solved using other formula. But at this time, we cannot solve this one using this formula because it is not allowed because of the variable x. So take note, you are only allowed if there is only a number difference with your dx. Now, what if you have the integral of, let's say, 3x squared plus 4 raised to 5x dx. So for this one, if we will use integral of u to the n du, then we have to check our u. Our u for this one is 3x squared plus 4. Our du equals 2 times 3, 6x dx. If you notice here, you have here your dx. You have also here your x dx. Therefore, this formula can now be used. So that if this is 6x dx, you have here 6. So I will write its reciprocal, which is 1 over 6. The integral of 3x squared plus 4 raised to 5. And then I will write here 6x dx. Okay. So that this is now our u to the n du. So 1 over 6. And then the integral of u to the n du equals u 3x squared plus 4 raised to 6 over 6 plus c. Our final answer is 6 times 6, 36. So you have here 3x squared plus 4 raised to 6 all over 36 plus c. Okay. To continue, we have number 6. So we have another example. Let's say the integral of 3x square root of, let's say, 4x squared minus 5 dx. So if we use the integral of u to the n du, then we will check our u. Our u for this case equals 4x squared minus 5. Our du equals 8x dx. Now if we rewrite this one, notice this one. If we rewrite, that is equivalent to 3. I will write first 3. Integral of 4x squared minus 5 raised to 1/2, and then our x here is dx. Okay. If you have noticed here, 8x dx, this one is x dx. For this case, x, I will transfer x to dx. And then 3, right first 3, so we have this one. So we have here x dx, we have here x dx. So the only difference is this presence of 8, number 8. Therefore, we can now apply this formula. so that our final answer is 3 times the reciprocal of 8, that is 1 over 8. The integral of this one, that is 4x squared minus 5 raised to 1 half plus 1, that is 3 over 2. 3 over 2 divided by 3 over 2 plus c. Take note, 1 half plus 1 equals 3 over 2. So this is 3 over 2. So that when we multiply this one, you have here, this is 3 times 1, that is 3 over 8. And then this is 2 thirds, I mean 3 over 2, transfer 2 as your numerator, so that is 2 over 3. Instead of 2 thirds, I mean 3 halves, this 2 becomes 2 over 3. This 3 halves, this 2 will be your denominator, I mean numerator. So that is equivalent to 3 times 2, that is 6 over, we will reduce this one to lowest term. Or you can, later on, you can reduce it to lowest term. 3 times 2, 6, 8 times 3, 24. Now, to reduce this one to lowest term, they are both divisible by 6. 6 divided by 6, that is 1. 24 divided by 6, that is 4. I mean 4, okay, 4. So 1/4. That means this is equivalent to 1 over 4, and then 4x squared minus 5 raised to 3 over 2 plus c. That's it. I will erase this one. Okay, another example, number 7. Number 7. Okay, so we will have the integral of 3 9 y squared plus minus a plus 12y plus 4 dy. Okay, we have this one, no? Okay, or we can make use of, let's say the exponent is 3 over 2. 3 over 2. That is our exponent. Okay. Or I will change this one so that the presentation is complicated. So we have here, just to be, so that this will be complicated to look. Okay, so we have here 9y squared. Okay, if this is our problem, then if this is in radical sign, we have to convert it into fraction. We have 9y squared plus 12y plus 4 raised to 3 over 2 dy. Okay, so we have here, I will write it here. Okay, 9y squared plus 12y. Now if we use this formula u to the n du directly, then our u will be, u is equivalent to 9y squared plus 12y. So that the derivative of this 9y squared plus 12y, that is 18y plus 12. So there is no, if you have noticed this one, dy. Okay. If you have noticed 18y plus 12 dy, and then this one, dy only, so I think you need to find another ways. You cannot do directly this formula, because you have your 18y plus 12 dy. So you have to find another way. So we have, we can write this one, if you are familiar with factoring, we can write it as the integral of, or we can rewrite it as 3y plus 2 squared dy. Okay, this is 2. Why did I have this one? If you have noticed, 9y squared. Square root of 9 equals 3. 9y squared equals 3y. So you have here 3y square root of 4. That is 2. We have this one. And so if I'm going to check this one, if they are equal, if I am going to square this one, okay, and then raise to 3 over 2. Okay, let me rewrite it. Okay, I will rewrite it. If I am going to square this one, that means 3y times 3y, that is 9y squared. And then 2 times 3, 6 times 2, 12y plus 12y plus 2 times 2, that is 4. If you have noticed, 9y squared plus 12y plus 4, they are equal. So instead of writing 9y squared plus 12y plus 4, I will rewrite it as 3y plus 2. Okay, and then of course our exponent is 3 over 2. That is 3 over 2. And then dy integral. Integral of this one, 3 over 2 dy. I will erase now this one. So that when we multiply the exponent to 2, it will be raised up into 3. So this is now equivalent to 3y plus 2 raised to 3 dy. You just multiply 2 times 3 over 2. You will cancel 2. What remains here is 3. So you have here 3. So that when we apply this time, we will now use this formula. U to the n du, our u is equivalent to 3y plus 2. And then our du is equal to 3 dy. This is 3 dy. This is dy. Therefore, we can now apply u to the n. So that if this is 3, so we will multiply its reciprocal, which is 1/3, and then integral of 3y plus 2 raised to 3, and then 3 dy. This is our 3 dy. Instead of writing dy, we have here 3 dy, and then because of 3, we have here your reciprocal, that is 1/3. So that this one now is your u to the n du. Therefore, our final answer is 1/3. And then u to the n du, that is equivalent to u 3y plus 2 raised to 3 plus 1, that is, okay, plus 1 divided by 3 plus 1. So that you have here 4 times 3, that is 12, of course, plus c. 4 times 3, 12. So our final answer is 1 over 12, 3y plus 2 raised to 4 plus c. That is our final answer for this particular problem. Now, take note, we have indefinite integral, indefinite integral. Okay, we have our initial formula, integral of integral of du, which is equivalent to u plus c, and then the integral of u to the n du, that is equivalent to u n plus 1 over n plus 1 plus c. This is our basic formula for indefinite integral. Now this time we will proceed to definite integral. Integral. Now take note also, for this one, we make use of U-substitution. using this formula. We apply U-substitution. For indefinite integral, we have the integral sign with your limit. We have our limits, let's say lower limits, we have here a, and then upper limits, we have here b. And then this is our function f of x dx. Now, how do we solve definite integral with lower limits and upper limits? So lower limits, upper limits. We go directly with our example to illustrate how definite integral is done. So example 1. So I think we only have 3 examples for definite integral. We go with the basic. Take note, the idea here is to apply indefinite integral and then substitute the limits. Okay, we go with the basic part. Let's say lower limits is 1, upper limits is 2. And then let's say x squared dx. Okay, when we solve this one, the integral of x squared dx equals x cubed over 3. X cubed over 3 with limits from positive 1 to positive 2. In some books, instead of writing x cubed over 3, we have this one with lower limits and upper limits. We can make use of this symbol. You have here notation, x cubed over 3. We can make use of this one from 1 to 2. Okay, instead of 3, I have here 2. Instead of writing this one, you can write it as you can make use of a bracket and then your lower limits and then upper limits. So you can choose, you can use any of these two notation. So that, okay, we go back here. This is your upper limits. All you have to do is to substitute your upper limits with your unknown variable. Your variable x. If this is the x, then your x. So substitute the upper limits first. That is 2 raised to 3 over 3. That is 2 raised to 3 over 3. We have this one. Upper limits minus the lower limits, 1 raised to 3 over 3. Which is then equivalent to 2 times 2, 4 times 2, 8 over 3. 8 over 3 minus 1 times 1 times 1 equals 1 over 3. 8 minus 1, that is 7 over 3. That will be our final answer. So this is how we compute definite integral. Upper limits minus lower limits. All you have to do is to substitute these upper limits and lower limits to your variable x. So 2 and then 1. Another example. Basic, we have here 2 plus xy dy. Now take note, from my previous example, we make use of x dx or y dy with only one variable. Now for this case, if you have noticed, this is dy. That means with respect to y, you have to consider x as constant for this case. Okay? Of course, we have our limits, let's say 0 and then let's say 2. So when we solve this one, integrate 2 dy, that is 2y. Okay, this is with respect to y, so 2y. And then we have here x plus, you have to consider x as constant because this is dy, so you only integrate y as with respect to y. So you have here x and then y squared over 2 with limits from 0 to 2. Take note, you have to treat x as constant for this part. Okay? So, because this is dy with respect to y, so you will only integrate y. That is y squared over 2. Okay. you have here, okay, upper limits 2. Instead of writing y, you will use substitute upper limits, that is 2 plus x, x, and then instead of writing y, you will use 2. 2 squared over 2. That is your upper limits minus lower limits. Of course, 2 times 0, the value of y, substitute the value of y as lower limits 0, plus x times 0 squared over 2. We have this one. So definitely this one is equivalent to 0. So that this one now is 2 times 2, that is 4, plus 2 squared, that is 4, divided by 2, that is 2 times x, that is 2x, plus 2x. That will be our final answer. So again, take note or always remember that when you use definite integral, all you have to do is to compute first its indefinite integral, and then after that you will substitute your upper and lower limits. Okay, so that is how we use definite integral. Last example for definite integral, we have 2x, let's say 2x cube. Let's say 1, 2, 3, 2x cube minus x squared over 3. Okay, dx, which is equivalent to the integral of 2x cubed, that is 2x to the fourth over 4, minus x cubed over 1/3 x cubed over 3, with limits from 1 to 3. You will have 2 over 4, that is 1/2, x to the fourth raised to, I will reduce it to lowest term, minus 1 over 9, and then x cubed. 1, 2, 3. I will change my limits to 0 and then 1 for me to calculate easily. 0 to 1. So this one now becomes 0 to 1. Okay. 0, 1, 0, 1. Okay. So I will transfer this one first. Okay. So that when we solve this one, substitute the upper limits, which is 1 to the fourth. 1, I mean, we have this one. Okay, 1 to the fourth over 2 minus 1 over 9 times x cubed times 1 raised to 3. Upper limits minus lower limits 0, 0. So 0 na. So that this is equivalent to 1 over 2 minus 1 over 9. Okay, so that you will have your final answer equivalent to 9 times 1, 9, minus 2. 9 times 1, 9, minus 2, that is 7 over 2 times 9, 18. Okay, so 7 over 18. So again, you can make use of your U-substitution in indefinite integral. When you solve definite integral, you can make use of your indefinite integral and U-substitution. So that's it.